Hi everyone, today we are talking about electrolysis. We will be going through the electrolysis of brine and talking about redox reactions and half equations. Now, you can split this word up into two, electro and lysis. Electro meaning using electricity, and lysis mean to break things apart. Lysis, to lyse, means to split apart. But what are we splitting apart? We are splitting apart a sodium chloride molecule in this case because it's the electrolysis of brine. And brine is salty water. Now, do you remember how sodium chloride formed? Well, it's an ionic compound, which means a sodium atom donated an electron to a chlorine atom. The sodium lost a negatively charged electron, which makes it positive, and the chlorine gained a negatively charged electron, which makes it negative. So when you rip sodium chloride apart, you get an Na plus and a Cl minus. Now, we're not just breaking the sodium chloride apart because this is a solution. There's water there as well. And when you break a water molecule apart, you get an H plus and an OH minus hydroxide. So those are the ions floating around in the solution. So this is the basic setup with electrolysis. We've got a container filled with an ionic solution. That's the electrolyte. The liquid is called the electrolyte. We have two terminals, a positive one, the anode, and a negative one, the cathode, submerged in the liquid, in the electrolyte. Now, the ions can act as charge carriers, so they can carry the charge from one terminal to the next. So this is a complete circuit, and electricity can flow through it. This diagram is a little bit more complex. Let's talk about what happens to each of the ions. So first of all, let's talk about the chloride ions. They are negatively charged, so they will run towards the positive anode. They will donate their electron to the anode, which will rush around in the circuit, and the chloride ion becomes a chlorine atom. It forms a diatomic molecule with another chlorine, and it bubbles off at the anode. So you get chlorine gas bubbling off at the anode. And you can test for that gas using litmus paper. It gets bleached. It goes white, bleached by the chlorine. Now, what happens to those H pluses, these H plus ions here? Well, they run towards the negative terminal because opposites attract. They pick up an electron and they stop being hydrogen ions now and they become hydrogen atoms. And just like the chlorine, they bond to form a diatomic hydrogen molecule and they bubble off and you get hydrogen gas bubbling off. How do you test for that? Well, you collect it in a test tube and you put a flame in it and you get this squeaky pop. So you may be wondering, well, hang on a minute, you haven't dealt with all the ions. You've only dealt with chlorine and hydrogen. What happened to that sodium plus and what happened to that hydroxide minus? Well, rather than running off to the anode and the cathode, they hook up, they join together to form sodium hydroxide. So the products of the electrolysis of brine are hydrogen, chlorine and sodium hydroxide. Chlorine is used in swimming pools as a disinfectant. Hydrogen is used to make ammonia, and also in large-scale manufacture of hydrochloric acid, and sodium hydroxide is often used to make cleaning products. Now, at the anode and the cathode, we have oxidation and reduction occurring. So this is redox, oxidation-reduction reactions. When hydrogen gains that electron, it's reduced. And when chlorine loses the electron, we can say it becomes oxidized. And if you struggle to remember which is which, just remember oil rig, O-I-L-R-I-G, and that stands for oxidation is loss, reduction is gain. Now in your exams you're going to have to remember which is which. What happens if you gain an electron? What happens if you lose an electron? So this is a good example for a question on oxidation and reduction. So let's finish up by talking about what's happening at the anode and cathode in terms of half equations. Now, at the cathode, hydrogen ions gain electrons to become hydrogen molecules. Now, when you do half equations, the first step is to balance the equation, and the next step is to balance the charges. We've got two hydrogen atoms on the right, so we need to put a 2 here, and that balances the equation. 2 H's on the left, 2 H's on the right. Now we need to balance the charges, and we do this by adding 2 negative charges here. 2 positive charges cancel 2 negative charges, and that's the correct half equation. You can see that hydrogen has gained electrons so it's been reduced. So there we are. That's the appropriate half equation. What about at the anode? Here we start by balancing the equation. So we've got Cl2 on one side and 1 on the other. So balance the equation. How do we do that? We put a 2 there, 2 on the left, 2 on the right. That works nicely now. But we have 2 minus charges on the left. Now we can't add positives to the left, so we need to add negatives to the right-hand side, like this. And that's the half equation at the anode. Now, that's it. That's the half equations involved in the electrolysis of brine. Now, I've only covered the electrolysis of brine here. It would be a very good idea if you complete your understanding by looking at the electrolysis of aluminium oxide and the use of electrolysis in the purification of copper. Those are 2 very good examples to have a look at. Okay, so there we are. Very brief run through of the electrolysis of brine, redox reactions and half equations. Here's some questions to test you. Answers coming in a second. Thanks again for watching, and I will see you next time.